Hey, welcome back to Fat Mama Physics. In this video, we're actually going to look at some decay curves on half-life, okay? So half-life of radioactive decay. So I hopefully will be able to get through all of these examples. So we'll see how it goes, at least for example 2. Below, we have a decay curve for the isotope mercury-203. Using the information presented on the graph, answer the following questions. What is the half-life of mercury-203? So remember, half-life is a time. So we need to look at the x-axis, but how do we know where to look? It depends on where the parent isotope halves. So half-life is a time for the number of parent nuclei in the sample to half, meaning half of it has decayed. Half of the parent nuclei have decayed. So if we take a look at when 50% of the remaining nucleus of the nuclei occurs, and then we do an interpolation here, which is going to be somewhere over here, and you will have to make an estimate on that. So that's 40. That's roughly about 46 to 47. Okay, so we're just gonna write about 46 to about 47, and the time is in units of days. Okay, so next up is B. The percentage of, we want percentage of the parent nucleus is left after 180 days. So again, we're going to perform an interpolation, and this is 150, 60, 70, 80 right here. And that looks like about, it looks like about 7-ish%, maybe? 7-ish%. So that, could be anywhere between 7 to 8%. It looks about 7%. Okay, it looks about 7% of the helium nucleus is left over. Okay, C. What sample of 100 grams? What mass of 100 gram sample of this radioactive nuclei would remain as the same isotope after 90 days? So I think what this question is saying is how much parent nucleus would remain after 90 days, okay? So let's take a look at the fraction first. So for 90 days, we do an interpolation again. This is going to give us about 25. That's 25, so that's going to about 26. My estimate, that's about 26, okay? So about roughly 26 parent is going to remain, okay? And 26% of the same isotope, so that's 26% of 100 grams. So if we take 26% of 100 grams, this is going to be roughly 26 grams left over. Since 26% of 100 grams is it is exactly 26 grams, but my estimation is about 26%. So you might get 27, you might get 25. Actually, that doesn't look like 25. But essentially, here we go. 26, roughly about 26 grams. So that wasn't too bad. We're done that example. So let's go on and maybe we'll tackle a few more. Okay, so example 3. The half-life of potassium-42 is 12.4 hours. How much potassium is left in a 750 gram sample after 62 hours? So we know that after one half-life, the amount of the parent is going to half, meaning we need to know how many half-lives have occurred to know how many times we need to halve our initial amount. So if we take 12.4 hours, so essentially we need to figure out the number of half-lives. This is 62 hours divided by 12.4 hours, and this is exactly 5 half-lives. Okay? Exactly 5 half-lives, meaning we need to have 750 grams 5 times. So if we take 750, we divide it in half, that's going to be once, and then divide it again, it's going to be twice. So essentially, if I divide this by half, this is essentially multiplying 0.55 times. So I'm going to take that to the power of 5. Okay? So that's effectively taking the half-life of 755 times. Putting that into my calculator, this is going to give me 23.437 grams. Rounding up to 3 sig figs, this is 23.4 grams. Okay? Don't need to care about kilograms because you're going to be left with whatever you start with is whatever you're going to be left with. So that's essentially that. Okay, so I'm going to do one more example, and then I'm going to save the rest of these examples for the next video, okay? A 50-gram sample of nitrogen-16 decays to 12.5 grams in 14.4 seconds. What is the half-life? We know the final amount, and then we know the initial amount. So what we could do, we know that all this time that the sample has been decaying is equivalent to 14.4 seconds. So we don't know how many half-lives have occurred. So the number of half-lives that occur divided by 14.4 seconds is going to give us the amount of time it takes for one half-life. So let's take a look at how many times it takes 50 grams to, how many times do we have to half 50 to get 12.5? Well, we know that 50 divided by 2 is going to be 25, and we divide 25 by 2 is going to give us 12.5 grams. So we have this 2 times, which means 14.4 seconds is equivalent to 2 half-lives. So if we divide this by 2, that's going to give us the time for 1 half-life, so which is going to be 7.2 seconds. Okay? And there you go. Okay? So that is what we need to figure out what the half-life is. Okay, so I'm going to stop this video here, do example 5, 6, and I guess this is 7 in the next video. So there you go, some half-life questions for you. No equations, just basically your understanding of what half-life is. Thank you for watching. Good luck. Phantom Physics signing out.